So our next point for discussion is the discharge over a step notch. So a step notch is shown over here in this figure. So this step notch is a combination of three different rectangular notches. So if you can see, let's see, this is a rectangular notch such that where length of the notch is L1 and height of the water above the crest of notch 1 is H1. You can see H1 is shown over there, and for the second notch, that is notch 2, so the height of the water above this notch is above the crest is your H2, and similarly this is the third notch, and above this third notch, this is the height of the water level above the crest. So this are respectively H1, H2 and H3. So in order to get the discharge of this step notch, and let's say the total discharge through this step notch is Q, so we can write the discharges we are getting from the notch 1, notch 2 and notch 3. So the only thing is left that we have to figure out the Q1, Q2 and Q3, and then just add this thing, we will get the discharge over a stepped notch which is shown on the figure. So first of all we will figure out the discharge of Q1. So if you look at this particular figure Q1, so Q1 is such that its length is L1. However, the height of the water above the crest of notch 1 is this H1. You can see, and in order to get the discharge through this particular section, we need to first of all use the equation such that it is having a head of H1, and then just subtract this particular thing such that it is also a notch having a length of L1. However, the head is H2. So we can write that Q1 is equal to 2 by 3, because it is a rectangular notch, so that's why we are using the formula, and the length of the notch above the crest is L1 multiplied by 2g, and then H1 raised to the power 3 by 2, and then minus H2 raised to the power 3 by 2. And similarly, if we want to figure out the discharge in Q2, we can write that this is 2 by 3. L2 is the length of the notch 2 and multiplied by the 2g, and similarly in the section, if we talk about the section 2, this will be such that whatever is the above this section, first of all we have to figure out this thing, and then we have to subtract the discharge in this section. So if we subtract this portion, we will get our desired Q2 value. So we can write it as that H2 raised to the power 3 by 2 minus S3 raised to the power 3 by 2. And similarly, we can write that our Q3, where we need not to go for any deduction, because for Q3 we are just figuring out the discharge flowing this particular notch section. So we can write that 2 by 3 L3 is the length of the notch multiplied by under root 2g, and then this is which is the height of the water above crest of notch 3 is S3 and raised to the power 3 by 2. So the only thing that we can write is that Q is equal to 2 by 3 under root 2g, that is common, L1 multiplied by in bracket H1 raised to the power 3 by 2 minus h2 raised to the power 3 by 2, then plus L2 h2 raised to the power 3 by 2 minus h3 raised to the power 3 by 2 plus L3 h3 raised to the power 3 by 2. And the only thing that in order to get the actual discharge, and with the consideration that all the notches coefficient of discharge is constant, so we can write that Q actual is 2 by 3 CD under root 2G, and then whatever is written above this one, that is L1 H1 raised to the power 3 by 2 minus H2 raised to the power 3 by 2 plus L2 H2 raised to the power 3 by 2 minus H3 raised to the power 3 by 2 plus L3 H3 raised to the power 3 by 2. So this is the equation for a stepped rectangular notch, and with the some numerical examples there we will illustrate that how to use such particular equation in actual condition. And the important thing is that if you are having a different CD values, such thing like CD1 CD2 CD3, we can also just multiply the Q1 Q2 and Q3 with the CD1 CD2 and CD3, and then we can get the actual discharge in the case CD is different for the each notch. So in the problem of the step notch, geometry of a step notch is shown over there, where three steps are there, 1 2 and 3. The dimension of each step is shown over there, which is 40 centimeter wide, 80 centimeter wide, and 120 centimeter wide. However, the height of the levels of the all rectangular notches is given. So the values which is given to us, I mean the problem which we have to solve is that we have to measure the what will be the discharge over this stepped notch. So let's start for the solution. So if we need to solve this one, L1 value is given to us, that is 0.4 meter, L2 is equal to 0.8 meter, and similarly L3 is given to us, that is 1.2 meter. However, in case of H1 value should be measured for the channel 1 from the top of this location. So the height between these two locations, or the you can say the height between these two locations is called as the H1, which will be summation of 15 centimeter plus 30 centimeter plus 50 centimeter. So that is going out to be 0.95 meter. So better we should write in the terms of the centimeter right now, and then we can write that H1 is equal to 0.95 meter. And similarly H2 will be measured from this location to this location. So this value is coming out to be 30 plus 50, that is H2 is equal to 0.8 meter. And similarly H3 is 50 centimeter, that is 0.5 meter. Now we will in order to find the discharge, that it will be the summation of all the Q1 Q2 plus Q3. So if we write the expression, so for the Q1 is equal to 2 by 3 CD1. For example, for this particular problem, the CD is considered as a constant value, which is 0.62 for all the channels. So without any confusion, we can write that 0.62 multiplied by the L1 multiplied by under root 2G multiplied by H1 raised to the power 3 by 2 minus H2 raised to the power 3 by 2. Now we'll put all the values. So this is 2 by 3, this is CD is 0.62 multiplied by L is 0.4 meter multiplied by under root 2 9.81 multiplied by h1 is known to us, which is 0.95 meter. So this is 0.95 raised to the power 3 by 2 minus h2 is 0.8. So 0.8 raised to the power 3 by 2. Now q1 value, if we solve, this is coming out to be 0.154 meter cube per second. Similarly, for the determination of q2, we can write that this is 2 by 3 into cd multiplied by the L2 multiplied by under root 2g, and in brackets h2 raised to the power 3 by 2 minus h3 raised to the power 3 by 2. If we'll put all the values, so 2 by 3 0.62, L2 is given to us, that is 0.8 meter, 0.8 meter multiplied by 2 multiplied by 9.81, and in brackets this is 0.8 raised to the power 3 by 2 minus 0.5 raised to the power 3 by 2. Now, so q2 will be, if we calculate, this value is coming out to be 0.530 meter cube per second. And similarly, in order to find the q3 value, this value is coming out to be 2 by 3 cd multiplied by L3 multiplied by under root 2g, and here the subtraction is not required, so this is h3 raised to the power 3 by 2. So q3 is equal to 2 by 3 multiplied by 62. L3 is 1.2 meter multiplied by under root 2 multiplied by 9.81 multiplied by S3 is your 50. So this is 0.5 raised to the power 3 by 2. So Q3 is coming out to be 0.776 meter cube per second. So if we figure out what is the total discharge through this step channel, that is Q1 plus Q2 plus Q3. So if we just note it down the values of Q3, that is 0.776 plus Q2 is 0.530 plus Q1 is coming out to be 0.154, that is your Q. So the final Q discharge, that will be 1.460 meter cube per second. That is our answer. We were